So welcome to 2.5. We're now going to be evaluating expressions that contain exponents. So evaluate those. Now 5 times 5 is 25. How do you say the next one? A lot of teachers even don't say this correctly. Now, you never say 5 2. That's not a thing, right? You could say 5 to the second power. But no 8th grader says it that way. We say what? We say 5 squared. And we'll go over why you say it that way in a second. But you say that 5 to the second power is 5 squared. Now the answer to that is not 10. It's what? 5 squared means 5 times 5. This too is telling you to multiply that number 5 twice. So the answer to that is 25. So what's the next one, and how do you say it? Again, you could say that is 5 to the third power. No one says to the 3. It's to the third power. But the way we say that in 8th grade and above is 5 cubed. And 5 cubed is 5 times 5 times 5. Right? It's not 15. We have a way to write 5 times 3. Why would we need this way? That's not a thing. So 5 times 5 we already said is 25, and now we have to do that. That's the multiplication dot, by the way. We often use that instead of x for times. And so this is 25 times 5. 5 times 5 is 25, and 5 times 2 is 10, plus 2 is 12. And so 5 cubed is 125, right? If you have 25 is like a quarter, 25 cents. If you have 5 quarters, you have $1.25. So 5 cubed is 125. So if x is 4 in these variable expressions, that's a way to write 4 times 4, which is 16. So you would say that is x squared, and we're going to do 4 squared, and 4 squared is 4 times 4 is 16, right? And then this is x cubed, and you're going to say that is 4 times 4 times 4, right? So 4 times 4 is 16, and 16 times 4 is 6 times 4 is 24. Whoops, not 84, is 64. 4 cubed is 64. So these little numbers have a name, and what's the name of them? Exponents. So we're going to be evaluating expressions that contain exponents. So you're going to do any exponents, these green ones, first. Then you'll do all your multiplying or dividing, and you'll still do your adding and subtracting last. There, it's always last. So let's learn some vocabulary first. This whole thing is called a power, right? And the little number is called the exponent. So we're going to copy the powers, then circle the exponent. All right, so we're circling the exponent. And the bottom number is called, or letter in this case, is called the base. And we're going to underline the base. The base literally means bottom. All right, the bottom of a lamp is called the base. So the little number is the exponent, the bottom is the base. The whole thing is called the power. So we say that as y to the 4th power. There is no special, once you get above 2 and 3, there's no special way to say them. You just say y to the 4th power. And so the 4 here is an exponent. The whole thing is the power. So what is that? Well, the exponent is 2. The base here is -8. And when you have a negative base, the parentheses are not optional. You have to put them. If you leave them out, that's a different problem. We're going to go over that. That's not what this is. The base here is -8. If the base is negative, it needs parentheses around it. And this means -8 times -8. That's what it means. So where is the exponent? We're not doing the math. We're just making sure we know the vocabulary. And the base here is 8. 65 is not really a base. There is an exponent there of 1. We'll talk about that. But the base here is 8. It's not, that's a minus sign. See here, that's a minus sign. So 8 is the base. In the other one, -8 was the base. Very important distinction. So in this one, the exponent is still 2. And the base now, we've put parentheses on it, is -8. Okay? And believe it or not, these have different answers. Here you'd have 8 squared, 64, and it'd be 65 minus 64, or 1. This, you do -8 squared, and you'd get 65, and -8 squared is positive 64. You'd add those two together, get 129. So those, all I did was add some parentheses, and it totally changes the problem because the base of the power changes. All right, so evaluate those and make sure you can say that. That's 11 squared. And 11 squared is 11 times 11, which is 121. That's 2 to the fifth, not to the 5, to the 5th. It's like the order of a race. Third, fourth, after 3 goes 4th, 5th, 6th, and 7th. So 2 to the 5th, not 10. 2 times 2 times 2 times 2 times 2 is what that is. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and 16 times 2 is 32. So 2 to the 5th is 32. Now that's so easy it should be sometimes hard. That's 10 to the 1st. That's how you say that. I should write that. 10 to the 1st. All right, you don't say 1, you say first. And that's 10. Okay, that's what that is. So now we're doing it with variables. So x squared here is 3 squared. We'll have y's in a second. 3 squared is 3 times 3, right, which is 9. That's x to the 4th. 3 times 3 times 3 times 3. Now you can multiply those in any order. So you could do 3 times 3 is 9, times 3 is 27, and then do 27 times 3. But because it's all multiplying, you can break the rules that we just learned. Yeah, when it's all multiplying, you can break the rules. It's commutative property. And so you can go 9 times 9, 81. This will come out 81 in any order you multiply those 3's. So there's y cubed. And by the way, this was x to the 4th. This is y cubed, and y cubed here, y is 10, 10 cubed. So that's 10 times 10 times 10. Well, what's 10 times 10? 100 times 10 is 1,000. All right, so now you can shorten these, right? We did steps 3 and 4 yesterday, right? Exactly the same, but in front of that, you have to get all your exponents done. So I have 5 times, and that's all right, so one of the things, look at my fonts. This is not X, that's a time symbol. The X symbol looks different. And so that's 5 times 8 squared. So you have to do your exponent, your 8 squared first, and that's 64, and then you do 5 times 64. Now 64 times 5 is 320. Now, there's always some people manage to get to 8th grade and not know a good shortcut. 64 times 10, what's that? Well, that's 640, right? There's this add a 0 rule for the 10 times table. Well, right, the 5 times table, which is what that is always half of whatever the 10 times table. So if 64 times 10 is 640, 64 times 5 is half of that. Half of 64 is 32, so half of 640 is 320. You've used that shortcut if you understood what I just said. Okay, so again, you got to get your exponents done first. So there's 5 squared and 2 cubed. 5 squared is 25. 2 cubed is 2 times 2 times 2, which is 8. Now, just like yesterday, once you get a step done, rewrite. So we still have multiplication, we still have addition, we still have division. So we got to get all our multiplying, dividing done next. So we have to do the 3 times 25. 3/4 makes 75 cents. So 3 times 25 is 75. 48 divided by 8 is 6. Then last, you get your adding done. And what is that? 81. So try this. This is 4 times 6 squared because y is 6. So you have multiplication and exponent. You have to do your exponent first. So it's 4 times 36. And then you have to do 36 times 4. 4 times 6 is 24. 4 times 3 is 12. Plus 2 is 14. And the answer to that is 144. And you say that as 4y squared. Let me write that out. 4y squared. And that means 4 times whatever y to the second power is. 4y squared. So this is 2 plus 3y squared. Well, we just said that we have to do the exponent first. 6 squared is 36. So we have 2 plus 3 times 36. 3 times 6 is 18. 3 times 3 is 9. Plus 1 is 10. So we have 2 plus 108, 110. So we're just going to make them more complicated. So here we have 2 times q squared. So 2 times 10 squared minus p squared. P is -4, and when there's a negative base, you must put parentheses around it, divided by 8. We have to get our exponents done first. So 10 squared is 10 times 10, 100. -4 squared, -4 times -4. 2 negatives make a positive 16. Now we got to get our multiplying, dividing done. 2 times 100 is 200. 16 divided by 8 is 2. So it's 200 minus 2. What's 2 lower than 200? It's 198. And I would do it that way, right? Instead of sitting there and doing this business, right? Just realize that 2 lower than 200 is 198. So 3p means 3 times whatever p is, minus q squared, q is 10, divided by -25. So we have to do our exponent first. I almost did the multiplying first. So I'm just going to make my life easier and write in this 100. And then 3 times -4 is -12. 100 divided by -25 is -4. We still have this minus sign here. So it's -12 minus, and that's a 4. It's a -4. So I need parentheses, right? Because we don't like minus -4 without parentheses next to it. So we're subtracting negatives. We're going to be adding the opposite. So instead of minus -4, we're adding 4. -12 plus 4, -8. And if you got that without my help, you got this. All right. So this is reinforcing what I said. All right, parentheses change the base. The base here is -9. So this is 0 plus -9 squared. So we do our exponent first. -9 times -9. 2 negatives make a positive, 81. So this is 0 plus 81, which is 81. The base here is 9. 9 squared is 81. So this is 0 minus 81. Right? That's not 81. That's -81. Right? Because you can't switch around subtraction from the last unit. So do these, they're different. So this one is -5 times -5. And notice I don't have to write the parentheses around the first one. Right? Again, I don't want this multiplication sign right next to the negative. So there's 2 negatives, make a positive 25. This one is different. The base here is 5. So this is a negative, not a minus sign, but this is, you have to do 5 squared first, and that's 25. So now you have the negative, and that one is -25. All right, so students want to be lazy and leave out parentheses with this. No way. You have to put your parentheses around your negative bases, or the problem is different. We hardly ever do this one. It's mostly this one, so most of the time, 99% of the time, you're putting parentheses around it. All right, we're at the practice. Notice I wrote parentheses around my -6. Negative 6 squared is -6 times -6, which is positive 36. Now we have 36 minus -4. We're adding the opposite. 36 plus 4, 40. This one is -7 times -7, the one we do most of the time, 49. This one is 49 with a negative in front of it. It's -49. See the difference? '81 times 10 is 810, add a 0, but it's negative 810. 144 divided by negative 144, well, 144 over 144 would be 1. So this must be -1. So what's negative 810 plus -1? Negative 811.